Now we're going to talk about critical numbers. A critical number, by definition, is a number such that the derivative of f at that point is 0 or it's not differentiable. And we're going to call those all critical numbers at f. So if we look at a couple of graphs where you have sharp points or corners, the absolute value function is an excellent example. The derivative doesn't exist when the right and left-hand limits are different. So this is a critical number. And remember on all of the problems you did last time, how the derivative at our max and min was always 0? Well, at a max or a min, you're going to have the derivative equal to 0. So you're going to wind up with a horizontal tangent. Now, let's try to find some extrema on a closed interval. Let's just kind of do one so I can step you through how to do it. The first thing you want to do is make a chart like this and put your two endpoints in, -1 and 2, and go on and evaluate those. All right, what is f of x at x equals -1? Due to space, I'm not going to show you all of the algebra, so let's see, f of 2 is, let's see, that's 16. All right. Now we need to find the critical numbers. To find the critical numbers, we need to take the derivative and set that equal to 0. So this is 12x cubed minus 12x squared. I'm going to factor out 12x squared from both. So this is 1, or x, excuse me, x minus 1. This is defined at all points on the interval. So where does f prime equal 0? Where x squared is 0, or at x equal to 0, and at x minus 1 equals 0, or x is equal to 1. So these are all of our critical numbers. Go on and put them in. I like to put them in order. Now, I have to evaluate f of x at 0. F of 0 is 0. And f evaluated at 1 is -1. So now I'm going to come through and find my largest number. That's f is 16. So this is my maximum. All right, and where's my minimum? Right here. So my maximum occurs at x equals 1, and my minimum occurs at x equals 1, and my maximum occurs at f equals 16. Your turn. Stop the tape and restart it when you're done. Now, relative extrema only occur at critical numbers. If f has a relative max or a relative min at x equals c, then c is a critical number. The proof is in your book, and it's an interesting proof. For time's sake, I will do it in class. But basically, you have to show that the limit as x approaches c of f of x minus f of c, x minus c, you have to show that this is 0. And this is one of the proofs where you show it by contradiction. So basically, you show that it cannot be true when x is positive. You show it cannot be true when x is negative. Therefore, you wind up with it having to equal 0. Now, guides for finding extrema on closed intervals. I've sort of already done this for you by example. The first thing you do is find the critical numbers in f. And the critical numbers in f will be where the derivative is 0 or where the derivative is undefined. You evaluate the critical numbers at those points. You evaluate the endpoints. The smallest is a minimum, the greatest is a maximum. It's a very straightforward process, but most students tend to forget doing it at the endpoints. So let's try a couple. Here we have 2x minus 3x to the 2/3. All right. First thing I want to do is take the derivative with respect to x. And I get that the derivative is 2, minus 3 times 2/3, x to the minus 1/3. So those are going to cancel. So this is 2 times 1 minus x to the negative 1/3. Now the critical points of this are not so easy to see. So remember, we're looking for things where the denominator is 0, and we have a denominator here. So let me get a common denominator. So this becomes x to the 1/3 minus 1 divided by x to the 1/3. So it's very easy to see now one of my critical numbers is going to be 0, and the other one is going to be 1. 0 when the denominator is 0. X is 0, or when x to the 1/3 minus 1 is 0, or x is 1. And then we put in our endpoints. Now let's evaluate the function at these endpoints. Where'd the pin go? Pin is not going to go. Okay. F at -1 is -5. F at 0 is 0. F at -1, F at +1, got carried away here, is 2 minus 3, it's -1. And then F at 3 is, now this is a little bit more complicated, so I'm going to show it to you. Can't quite do this one in my head. This is 2 times 3 minus 3 times 3 to the 2/3. Now for simplicity's sake, I'm just going to stick this in my calculator. And I get negative 0.24. Now let's find our extrema. Our largest value is 0. So this is our maximum. And the smallest value is -5. Your turn. Stop the tape. Do the problem. When you're done, come back. I want to show you another one. Now what do you do when you have these funky trig functions? All right, it's very obvious where the maximum is going to be, but it's kind of iffy here where the minimums are. Are these equal? Are they close? Well, let's start by taking the derivative. F prime is 2 cosine x minus 2, derivative of cosine is minus sine 2x. Now, the deal with trig functions is sometimes you have to massage the equation a little bit. Let's use a trig identity. Sine 2x is 2 times 2 cosine x sine of x. So I'm going to factor out 2 cosine x from the entire thing. So this is 1 plus 2 sine x. All right, now on this interval, where is cosine 0? Well, cosine is 0 when x is pi over 2 and 3 pi over 2. All right, so I'm going to go on and start filling this in because it's going to get kind of full here. And I'm going to wind up not putting them in exact order because I want to put all of the first ones. I mean, it's okay if they're not in absolute correct order. All right, so that's when cosine is 0. Let's look at where 1 plus sine 2x is 0. 1 plus 2 sine x is 0 when sine of x is -0.5. Now on this interval, where does that occur? Well, that occurs when x is 7 pi over 6 and 11 pi over 6. Okay, so those are our two numbers here. It's hard to write at the bottom of my board here. And 11 pi over 6. Now go on and evaluate these. I've kind of run out of room. So I'll just tell you what the answers are. F at 0 is -1. F evaluated at pi over 2 is 3. F, evaluated at 3 pi over 2 is, that's -1. F evaluated at 7 pi over 6 is -1.5. F evaluated 11 pi over 6. It's also -1.5. And then F evaluated at 2 pi is -1. All right. Now, it's just a matter of finding our extrema. What is our maximum value? Well, that's right here. It's our max. Now, what's our minimum? See, this one's interesting because it has two minimum, both 7 pi over 6 and 11 pi over 6. So it turns out those were actually equal. So they're both minimums. Can you have two minimums? Yes, of course you can have two minimums. But we know there has to be at least one. All right, your turn. Finish this. When you're done, turn off the tape and finish your homework.